Hello students, welcome to my chapter binomial theorem. Today we will deal with this binomial theorem where at first I will ask you what do you mean by a binomial. If I ask you what do you mean by binomial, this particular term binomial is related with a term which is called as polynomial, which is related with a term as polynomial. And polynomial normally are in the form of p of x, where p of x equals to a naught x to the power n, a1 x to the power n minus 1 and so on. So this is the combination of monomials. This is the combination of monomials. So when a single term out of a polynomial is taken, it's called monomial. And when two terms out of this polynomial is being taken, it's called as a binomial. So a binomial normally is in form of a naught x to the power n plus a1 x to the power n minus 1. So this will be called as a binomial. Simply this deals with variable 1 with some power and variable 2 with some power. That's why we take it as x and y is just for convenience. So this form of x plus y is being called as binomial. So what do we mean by binomial theorem and what we are going to deal with this binomial theorem? It's specially nothing but the expansion of x plus y to the power n. X plus y to the power n. This particular expansion what we are going to deal with is called as binomial expansion, and the theorem behind it is called as binomial theorem. Okay. So we will be moving into that. So as you know, what is the value of x plus, if I ask you the value of x plus y to the power 0, then you can easily answer me the value is equals to 1. Then if I ask you that x plus y to the power 1, the value will be equals to x plus y. If I will ask you x plus y whole square, the value you will easily can say x square plus 2xy plus y square. So in this manner, if I want to write x plus y to the power 3, then you can say x cube plus 3x square y plus 3xy square plus y cube. Now in this particular manner, we are accustomed with these particular formulas up to x plus y to the power 3, which we call a plus b whole cube in some extents. But whenever we will ask you that what will be the formula for x plus y to the power 4, then this is not in your memory that the formula of x plus y to the power 4 will be starting from x to the power 4 and will end at y to the power 4. And this particular formula I can write out of here, and that will be x to the power 4 plus 4 x cube y plus 6 x square y square plus 4 xy cube plus y to the power 4. You may be amazed of this particular thing, how I could manage to write this formula so simply, so easily. So this particular way in which I have written this particular formula is through the help of a particular triangular arrangement which is called as the Pascal's triangle, Through the help of this Pascal's triangle, I got to know about this particular formula. Let's know about that Pascal's triangle. Okay. So now what I am observing over here is nothing but the power of x over here. The power of x plus y is 1, and the power of x is 1 over here, and y power is 1 over here. Down here, if I go x plus y to the power 3, the maximum power given here is 3, and the power of x starts from 3 and it goes on decreasing down the line. And power of y goes on increasing down the line. Means the power of x is 3 over here, then power of x is 2 over here, then power of x is 1 over here, and down the line as we move, the power of x decreases. Down the line as we move, power of y increases. So that particular phenomenon is being going on through all the particular formulas. But if we want to say about the coefficient, about this coefficient, we do not have any particular phenomenons of till now, so that we can find out these particular coefficients. So what we are much bothered about is to find out the coefficient of x plus y to the power any integral power. So now I am erasing all the variables out of here. I am erasing all the variables out of here, and in place of variables I am just writing down their coefficients. So just observe, I have wiped out the variables and in place of them I am writing down their coefficients. Over here for x square the coefficient is 1. For 2xy I can write the coefficient as 2. For y square I can write the coefficient as 1. Again for x cube I can write the coefficient as 1. For 3x square y I can write the coefficient 3. Just like the manner I have written down the coefficients down here. And again for all of them I have written down the coefficients 1, 4, 6, 4, 1. If you observe them very keenly, then you can find that all the border values are possessed by 1. All border values are possessed by 1. And the between values have a manner just like 1 plus 1 equals to 2, 1 plus 2 equals to 3, 2 plus 1 equals to 3. Over here 1 plus 3 equals to 4, 3 plus 3 equals to 6, 3 plus 1 equals to 4. And other border values are 1. So I want to interview yourself that what would be the value of x plus y to the power 5, and if I am only bothered about the coefficients, then I think you can find out the coefficient, and the coefficients, the border values will be equals to 1 as usual, and the between values will be the summations of the above two. So 1 plus 4 it will be 5, 4 plus 6 it will be 10, 6 plus 4 it will be 10, and 4 plus 1 it will be 5. So this particular triangular arrangement is called as Pascal's triangle, from which we get the coefficients of x plus y to the power n. In this particular coefficient findings, we can easily arrange the variables and we can find the expansion of x plus y to the power 5 out of there. So the manner what we have observed just before told us that x plus y to the power 5 or any x plus y to the power n, we got to know about that the power of x will be maximum at the first place and then it goes on decreasing, and the power of y will be minimum at the initial phase and it goes on increasing. That's why I can write over here this will be 1 into x to the power 5, because the maximum power over here is 5. That's why I can write 1 into x to the power 5 plus 5 into the power of x will be decreasing. That's why 5 into x to the power 4, and the power of y will start increasing. That's why y to the power 0 was there. It will be y to the power 1. Then the next one will be x cube into y square. Next one will be x square into y cube plus x into y fourth, and the last value over here 1 was there, and the last value will be 1 into y to the power 5. Okay, so this much is all about the Pascal's triangle. So from that particular Pascal's triangle we can find out the expansion of x plus y to the power n through the method of finding out the coefficient just by the addition and sharing the border values by 1. And the next phase is distributing the variables in the form of ascending order of y and descending order of x from the nth power. Okay, it's all about the Pascal's triangle. In the next session we will be dealing with the formulation of x plus y to the power n, in which we will find that x plus y to the power n for any power won't follow this particular way of Pascal's triangle, but the findings of this Pascal's triangle will be useful to find the x plus y to the power n formula, which is called as binomial expansion. Thank you. I am Saubhagya sir, and I am teaching you this particular chapter, binomial theorem.